All right. Good afternoon, everyone, and welcome to the last session of the day, deep dive on the Ballard Passive House project. I'm Helen Harrison. I am a committee member for the Slam and Summit event, and we've got Wendy Ferry with us, who's helping out on support. You'll see her listed in the chat participant box there as a speaker. If anyone has any technical issues, just send her a private message using the little chat icon in the chat box there, and she can help you out. Just a quick note to orient yourself to Remo. For a better presentation view, you can minimize your chat bar by selecting the green arrow that's pointing right in the top right corner, and that'll open up the screen for you. And then any video or screen that you would like a bigger look at, you can make full screen by selecting the white corners or white arrows in the top right corner of your box. Wendy, would you do me a favor and share your screen for me? Awesome, thank you so much. All right, and if you can go to the next screen for me as well. I'd like to take a moment to honor the land that we currently occupy. On behalf of the Northwest Eco Building Guild, we do acknowledge that we are all on the traditional land of the first people of this region. We honor with gratitude the land itself and thank the tribal people who have been faithful stewards of the land, water, and ancient history of life. Here in Seattle, where I currently am, we are on the land of the Duwamish. Many of us are attending the summit from other parts of the region or even out of state. If you currently don't know on whose traditional land you work and live on, we encourage you to find out. There's a link down there at the bottom of the slide. You can see, you just copy and paste that into your browser. Wendy can also paste it into the chat for everyone to copy and paste into their browser. It's kind of a neat site. So we're all here today because of our interest in sustainable building. For those of you who have been part of the Guild for a while now, you know that our unofficial motto is pushing the envelope, and on a literal level, we're often talking about the physical envelope of the building, but one of the most impactful envelopes we can push is about people. It's about equity, social justice, and climate justice. So as you attend our sessions, well, this session and next week's sessions, we invite you to keep this aspect of sustainability in mind. We invite you to be a part of the Guild's journey in helping bring light to this area of work that's so critical for building a brighter future for the 7th generation. We also would not be able to do this without our sponsors. We've got our sustaining sponsors, Dunn Lumber, King County Green Tools, and Pharos Creative. They've been a big part in helping us make this happen. Additionally, we've got some supporting sponsors, many supporting sponsors, as well as contributing sponsors that are all making this happen for us. Throughout our sessions, we do have sponsor tables scattered throughout, so we encourage you to stop by and meet them, see what they're all about. One last thing before introducing our speakers today, I do want to orient everyone to Remo if you're joining a session for the first time this week. It's a new platform for us with pretty great user experience, and we hope you'll get a lot from it. You will see on the right there's a little icon that's enlarged. There's a yellow star for anyone that's a host. They're floating around each of the sessions. I'm a host, Jenny is a host, and there are a couple of others around that you'll see a yellow star. You can send them a private message if you need any kind of help or support. Additional help areas are in the corners of the floor plan here. In the top left, you can see outlined in yellow basic tips and support. In the purple circle next to it, you can select that to check to see if you have any mic or camera issues. If you want help from us from the help desk, you go to the lower right corner of the floor plan, and the hosts are keeping an eye on that table area so that we can pop in if there's somebody sitting in there. And last, if all hell breaks out, you can contact Remo support in the lower left corner. Again, Wendy Ferry is here helping us with the Q&A session. We're going to save all questions to the end, but feel free to put them in the Q&A section throughout the presentation. We'll also be monitoring the chat in case you end up putting some questions in there as well. This course is approved for 1 CEU. Sorry, Taylor and Kevin, I only got 1 credit because I didn't realize it was going to be 90 minutes when I submitted it. But if you have not picked up an AIA reporting form, we've got them available to you. Wendy can put it in the chat box for you to grab and download. And that'll have all of the sessions we've got for the entire conference mapped out for you. So all you have to do is check the boxes of the sessions you do attend live and then email them to us. And without further ado, we've got Kevin Witt and Taylor Calloway from First Lamp Architects. Wendy, you are welcome to turn off your screen sharing. And Kevin and Taylor, if you want to jump on stage here by turning your microphone and camera on. If any of you are with us who have attended the first night of the Green Building Slam, you might remember their faces. Today they are taking a deeper dive on the Ballard Passive House project. And I don't know if Tom Balderston's going to be joining us, but if he is, and you find him in the chat box, he was the Passive House Raider on the project. Welcome. Take it away.
Thanks, Helen.
Thanks, Helen.
All right.
Thank you, everyone, for coming. Not sure, like Helen said, not sure how many of you are familiar with the projects from our talk. This will be a little bit deeper dive into the projects. Again, I'm Kevin Witt. I was the builder. We both are founders of First Lamp. So my role in the project was on the construction side. And I'm a passive certified builder. This is Taylor Calloway. He was the lead architect on the project and the certified passive house consultant. And so that's it. We'll kind of keep going. The title of this, we're building an oasis in a toxic world. We will kind of go into what that means as we sort of move forward.
Yep. Let's just jump right in. So when you're building a passive house or any high energy efficient building, you know, through the process of doing this, we kind of narrowed our focus into 3 main objectives. The first objective is you've got to get the flow of energy right. The next is you have to get the flow of natural light right. And you also have to get the flow of air right. So that's what we're going to focus on. The first of those being the flow of energy. So 4 big points we're going to talk about for energy is siting and orientation. That's critical. Everyone that's familiar with passive house kind of knows that a big part of that is just how the building is kind of connected to basically the sun. Window locations, the building envelope, of course, and thermal bridging. So all of those having to do with, keeping the flow of energy. So yeah.
Some of the things that you may have heard before, a lot of the decisions or a lot of the forces that make building a passive house either easy or hard are decided at the very beginning. So if you have the opportunity to work with clients on selecting a site, find one that's got good orientation. We're going to go through all of that, but the more that you can, from the outset of the project, sort of stack the deck in your favor and kind of learn what to look for in a site. A lot of the things, and all those things are free also, by the way, right? So just orienting the building correctly, making sure that it's like the passive with the lowercase p, all of those principles are in place. All that's free. Those aren't materials. They don't cost any money. So lots of leverage in the beginning.
So this project's located in Ballard, as the name would suggest, neighborhood Seattle. It's in a fairly tight urban lot. So one of the challenges on any kind of tight lot where you've got a lot of houses next to you is kind of create the opportunity for that solar gain we're looking for. So in this case, what we did was the house, we stretched it out on the east-west axis. It's long. And on the south of that, one of the most critical parts was we detached the garage, and then we also created this courtyard. The courtyard was also a big part of the program for the clients, luckily. They wanted an outdoor space that allowed them to kind of connect to the outdoors in a tight lot that was also safe, secure, and private from their neighbors in the street. And so that really afforded us the opportunity to put that on the south side, pushing the house north. So the red arrows kind of represent the sun coming from the south, pushing the house north to maximize that southern exposure. And then we stretched the house along the east-west direction also to make it as long as possible. So you can see it's really short in the north-south direction and really long along the east-west, again, maximizing that southern exposure.
And in this climate, what you really come to learn, like Taylor is saying, all of your leverage and all of your control of solar gain happens on the south. The north, windows on your north elevation more often than not become a liability just for heat loss. And windows on the west become a liability for overheating. So what you really end up doing is focusing a lot of your attention on the shape and proportion of those windows on the south. It would be a difficult project and something that would be a lot more tricky to accomplish a good balance of kind of solar gain and heat loss if your primary view was on the north side or the east side or the west side, right? So this is one of those site selection and orientation things.
So the second floor just kind of shows, we're going to talk more about orientation, but how it's basically stacked over the floor below. It's also long and linear, southern exposure, and also try to keep the box as simple as possible. A big piece of helping control costs and making the project feasible, for especially a passive house, is definitely making it as simple as you can. So another good example of that is the section. So, on this project, we definitely did a lot to keep it as simple as we could. But of course, because of there was some client-driven scope, which included kind of creating a sense of a little more privacy and security from the street. So they wanted the house to be lifted up off of the street a little bit. And so by doing that, you can see the section on the left where the green arrow is showing kind of a jog that's below the house. So what we had there was a little bit more complexity. Architecturally very interesting, pretty cool, but additional challenge we had to solve.
When we were doing our preliminary blower door, this is jumping ahead a little bit, but just as one of those ways that you can kind of see that even one little jog, a little bit of a crawl space, kind of a tight space to get to, it's harder to air seal that. And so in all of our preliminary blower door tests where we're kind of testing the tightness of our envelope, that tiny little pony wall that that orange arrow is pointing to, most of our air leakage was coming from that. And when you need to eliminate every possible hole and unintentional crack, stuff like that becomes a real pain in the neck. Pain in the neck means time and money. So it's hard to overstate the importance of just keeping the shape of the house as simple as you can to kind of set yourself up for success.
So, courses, I think we're all aware of. We're in the Northwest here, and what's a very it's cold climate. So heating dominates our energy use. That's kind of what that represents. So as far as layout and orientation, this is just additional kind of reinforcing of kind of how we laid everything else. This is the picture you see on the bottom left, is kind of a bird's eye view of that south facade. Big windows, lots of light, lots of glass in that courtyard. Again, the courtyard concept showing how we were able to push the house away from the neighbor so that the shadow lines from that house were landing in the courtyard and not on the facade. That's, again, allowing for more of that, the solar gain that we're looking for. So this image here is a section showing the courtyard and kind of showing how that solar gain works. In a passive house, kind of say the small p passive is, you're wanting the house to be heated by the sun, and that helps reduce energy costs, thermal comfort, and all those kinds of things. So what you have here is you see, that's the sunlight coming in the windows, heating up the occupants, heating up the space, taking off some of the energy load from your heating system. Up above that is we also angled. The purpose for that angled roof form is for solar panels. Those are all kind of prep for that maximum exposure again, and create the best opportunity for that energy flow. So just kind of a blow up of that section again, showing this view, showing the windows. This shows here, to kind of put a finer point on it, the south is the easiest light to control, right? So the sun is highest throughout the middle of the day. With solar shading, you can have the windows be shaded in the summer when you want to block the windows, and you can have the windows be exposed in the winter when the sun is much lower. So the south side is always what you're looking for from a passive layout standpoint. Of course, you see square windows most of the time are going to be more efficient. We're going to go into that more on a different slide, but this just kind of points. We did that in most places, not in all, and we'll talk about why, the pros and cons of some of the decisions we made with the windows layouts. And of course, this again, south-facing roof for solar panels, both over the block in the back, and then also the roof over the main part of the house.
Oh, one of the things that drew Taylor and I to Passive House and FIA certification in particular is the complexity and the resolution of the energy model. We used the Wolfie model to demonstrate that we kind of met compliance and that we met the FIA standard. And the right half of this slide is an example of the output that you get from that. So the title of this, in case it's hard to read, those color bars on the right, that's solar gain by windows. So the blue bars are solar gain during the heating period. The red bars are solar gain during the cooling period. And so you get an output for every single pane of glass in the envelope. And so you really can monitor which ones are your best performers, which ones, are really dinging you on solar gain during the cooling period, right? Which is what you don't want. And so even just as a means of illustrating the top left photo, each one of those panes, that's a sliding door. Each one of those panes is entered into the model separately. The pane on the left received more gain than the pane on the right because the model knows that the building, the L shape of the building is blocking a lot of the sun from that right pane. So there's different output there. So that type of resolution, it helps Taylor and I learn what really is acting on the building and on its modeled behavior so that we can come closer to real world conditions.
Yeah, and it was great. We're actually doing all that in real time as we're designing the house, because we were doing, the energy model while we were designing the building. So this wasn't something that was like, oh shoot, we should have known that. We were actually making these decisions as we went along.
Yeah. And, the other thing that we should call out on this slide. So the best performing window was actually the pretty short but high windows that were tucked up underneath the awning in the bedroom. And so that's the bottom right-hand picture. You can see, the orange arrow coming from there. But again, like Taylor mentioned, no summer sun hits those windows because of that shade. But in the winter, the sun sinks down low enough, it's going to make it underneath that overhang. So you get the gain in the winter. You have no problems in the summer with excess gain that way. Ready?
Yeah.
All right.
This is just a diagram again showing how we thought about the future, the time future now going in soon. So photovoltaic system, sorry. Yeah, so these two sections of roof are sloped to the south to maximize gain. You could use the other parts, but these are the most efficient layouts. And we kind of played that into the architectural expression as well. So bringing that out to the front. So basically it's just, so there's the zone for electrical panel. We had all the conduit put in there, and it was ready to go. But so integrating the design to think about future solar panels. So west elevation. This is one of your biggest liabilities. So because the sun sets on the west side, it's going to be much lower and harder to control. So it's that side of the house you want to watch out and be careful for how many windows you want to put on that side.
Yeah, when we began the design, these two windows that we've highlighted there in yellow, those were floor to ceiling windows, right? And they're much taller. And what we found as we were kind of massaging the energy model, like Taylor mentioned, we kept, we weren't in conformance. We had to get this thing under. We were having problems with gain, and those windows just we'd shrink them by a couple of inches, and it's like, no, that's not enough. Let's do it a little bit more. And so we kind of wound up with the windows that we have. In this particular instance, we got a little lucky because the owners did not want the inside of the house to look out onto the street. They wanted the opposite. Had they wanted that, which often clients do, they want to look out of their living room window and see the streetscape outside. Had they wanted that, it would have been very difficult. We would have done some sort of vertical louvered shading or something to that effect so we can control that western sun.
Now, which you can do, but again, that just can drive up cost and schedule. So, in the spirit of passive house, again, small p passive, we're definitely trying to, respect the sun as much as possible. Yeah.
And ironically, we also, the clients also spend a fair amount of money with the wood detail that you see over there to compensate for the fact that there are no windows over there. And when you look at this in plan, that entire western facade is pretty much in the same plane. So all of the stuff that you see, the sort of wraparound, the sort of slatted wood detail that's on that elevation, frankly, those are all just kind of architectural sleight of hand to make the building look thoughtful and sensitive to the neighborhood while you have hardly any windows and the entire facade is in one wall plane. So that was a kind of a secondhand challenge on this one.
Of course, this is showing the north, and we really have as few windows on that side as possible. Basically, every window on the north side of the house in the northwest or any northern hemisphere is just basically a net energy loss. There's no solar gain to compensate for the loss. So being on the north side, you want to be real careful. Again, on this project, we lucked out. It was on close to a property line and a neighbor, so it wasn't too difficult to work around it. So that's one of the things that worked out. Okay, now envelope. So, like a lot of folks you may or may not know about passive house, but one of its things it's notorious for, of course, is how much insulation they have on the outside. We're collecting all this solar energy. We've got the solar panels. We're doing great. We're creating energy on the inside. We got to keep it in though, right? So in order to keep it in, that means there's going to be just a whole lot of insulation for the most part. Yeah.
Yeah, and so whenever I took the passive house builder training, it was like 2014, I believe. I thought we were going to spend most of the week talking about insulating, but really you kind of start to begin to worry about vapor drive. So insulating a house is pretty easy. You need to be careful with your product selection as you move forward, making sure that moisture can move in and out and doesn't get trapped. But the basics of this wall, what we did, it's 2x8 studs, and we filled it with blown in fiberglass. So bibs insulation, that part's pretty standard. And then on the exterior of the house, we used Gutex ThermoSafe. It's wood fiberboard instead of foam. So we like the carbon capture component of it because it's recycled and repurposed wood. It's rigid, so it's easier to work with than some of the mineral fiber insulation that's out there. Easier to install siding over the top of it. And it's great for vapor drive as well. Vapor moves through it pretty well. So
yeah. So and I think we checked with Lucas, the 475, but we were one of the first projects, certainly in the area, but in North America, used that on a home. But yeah, it's great. Global warming potential is real low, and I think it's probably good.
So yeah, there it is in practice. So the walls wound up being about a foot thick, a little over. There was about 10 inches of foam underneath the slab. And then the roof was, there's a variety of thicknesses, but it averaged about 30 inches. We had a 16-inch truss that we filled with blown-in fiberglass, and then we put varying thicknesses of foam on top of the roof trusses. We've kind of, even when we're not designing passive houses, like our standard house in our office now, kind of shied away from vented roofs because of the difficulties that presents with air sealing. We like foam on top of the sheeting. That's kind of our favorite roof assembly. But when you insulate the exterior of a house, you know, you got to worry about your window bucks, and you got to make sure your window detailing becomes a whole new thing. We'll get into that in a few slides here.
So the next big part of this is thermal bridging, and kind of what Kevin was referring to earlier about the parts of the exterior design being sort of on the outside. That's a big part of passive house. You know, passive house is almost like, think about it as a beer cooler with a couple of windows in it, and any of the stuff on the outside you want to kind of hang on the outside and not break that thermal boundary. That being said, we have earthquakes. We live in the Northwest. That's, you know, so the details of how that works out isn't always as straightforward as it may seem.
Our structural engineer loves it because he kind of told us one time after we had done a few of these, and he said, you know, energy, like conserving energy, you don't want anything to connect. Everything wants to just kind of float next to each other. But structural engineers like for things to connect. And so, like, that's kind of the fundamental. You find yourself detailing around and finding ways to accomplish what you need to accomplish without a lot of these kind of wood to wood, or you're bolting steel directly to wood, or whatever it is. You end up having to eliminate those thermal bridges as often as you can. This is an example that we did at the slab edge. It's remarkable to Taylor and I how little foam it takes to effectively make the thermal bridge disappear, right? So we have 10 inches of foam under the slab. We only need 4 inches of foam in between the edge of the slab and the stem wall in order for that effectively to stop or significantly slow down heat transfer through there. So we had a little custom extrusion. We put a little 4-inch square of foam around the perimeter, and all we did was we put the capillary break, the crushed rock in first under the slab. We did the sub-slab foam, put the vapor barrier on top of the foam. That's the black that you see in that picture. Then you put the EPS thermal break. That's the 4-inch square there. A little trick that we learned also, if you chamfer that back edge, you can kind of see it in the detail there. That keeps your capillary break. If the corner of that membrane webs at all, then it's very hard for you to securely install that 4-inch thermal break there. So we chamfer that corner, and then hold it down with, go ahead and install your mud sills, so that holds that in place. Otherwise, if you didn't have that, you would pour your slab and the concrete would just make the foam float up and out. It'd be very hard to kind of secure that down. So instead of spending money on a temporary brace or trying to weight it down, we just went ahead and installed the mud sills and then poured the slab there.
Thank you to Dan Whitmore.
Oops, what did I do? I messed something up.
A little technical. Start it over.
Oh,
Sorry.
Oh, there we go. I don't know why that went. Okay. Hit B instead of the space key. And,
sorry, guys.
All right.
We're back. I hope.
Mud sill to hold.
Somebody will jump in.
Somebody
will jump in. Okay, cool. Yeah, so thermal bridging. So these are exciting little models here. These are these are called therm models. You can see this is a section of the detail we just showed you. We'll make this kind of quick, but on the left side, you can see the way it was installed. It actually could have been a little better. You can see what was, if we would have put 1 inch of EPS on the exterior face, what you're seeing there is the blue part is not coming into the building as much, and you got a little bit more of a uniform flow of energy, the red being hot, the blue being cold. And so this was a little bit of a lesson learned. We didn't actually do it this way. It's still certified passive house and everything, but this just kind of shows it would have been about a 10x better performance for just that little bit of EPS on the outside. So definitely recommend doing that. This is just more thermal bridging. This is a good example of one of those details that we did that didn't necessarily follow along with the kind of rules of thumb of attaching everything on the outside, but it really helped also to have that fin so close to the window. So there's kind of a trade-off in benefits there. Also, it looks really cool. So, but mainly something like that really needed to attach to the building and be really secure. So you can kind of see this was a place where we took a little bit of a hit on the thermal bridging, but we did it only in a few isolated places. So it wasn't too bad.
Yeah, so you can see there's that blue arrow, that sort of icy finger of death that's coming in. You can see the way these color bands in the wall section sort of dimple in. That's because that steel canopy over the windows is acting as a heat sink. It's bolted directly to the sheathing. Heat transfers from the inside of the house out to the sheathing, and then, man, once it hits that metal plate, it draws out very fast, right? So the heat is going to really draw through the edge of that plate. So that's what that is. That's a representation of that. Like Taylor said, you're going to find, like, we're talking about trade-offs here. When you're able to see the way energy moves so distinctly, you're going to realize that there's not really a perfect solution. You trade kind of for the better, like, and you need to be able to kind of make decisions to say, well, we lose a little bit of this performance, but that's exactly the window placement, the canopy placement that we want. We'll take the hit on the thermal bridging. We'll model it to see how big the hit is. But in the end, we decided, like Taylor's saying, it was worth it. But this is a detail we know everyone in the industry is kind of continuing to refine, because you always have these shades on the south side. Like, it's kind of one of the cornerstones of the industry. Ready?
Yeah. Yeah, I'll let you.
Okay. So the windows are tricky. Often they're holes in your envelope. And so insulating around those is incredibly tedious. The picture I'll do the picture on the right first. We have Helen to thank for the picture on the left. We'll get to that one. She called us out on that one in the nick of time. Yeah, so in the picture on the right, this is an exterior shot. We already have the exterior insulation installed on the wall. But next to those plywood bucks, that's just 1 inch of EPS foam, the white foam. And in the detail, you see where the blue line is. The exterior of that detail is on the left-hand side. So before you put your finished jam extension on the outside, all it takes is 1 inch of foam to keep the window jam itself from being uninsulated, right? Because as with any window, you have shim space. You can't let that kind of be out to the open. Then the picture on the left is the interior. And so the way that we built our jam extensions on the interior is, instead of shimming them and installing them directly to the studs, we had all of our carpenters kind of build these picture frames on the floor, set them into space and shim them, and then install them. Well, we had more shim space then. And Tom Balderston and Balderston Associates was our rater. Helen came out, and it was like one of the first things she said. She's like, "What are you guys going to do about that?" And I made something up real fast. I said, "We're going to cram some insulation in there," which was absolutely right. That's what we were supposed to do. A little trick. In order to do this work, it's incredibly tedious. We all know if you just cram bats in there and they're too dense, then it doesn't work the way as well as they should. So I found the carpenter on our crew that had the least experience. This was his first job ever. he had no idea how tedious and ridiculous this was because he's got no point of reference, no bar. And he was very good at this. He did an excellent job. He didn't feel like he needed to hurry. He went the exact right pace of just carefully poking. He had a coat hanger in one hand, I'm not kidding, and just sort of lightly tucked batt insulation on the inside around all of those windows, right? These are the types of things that really matter. That if you're going after that last 10% of performance in your kind of performance curve, these are the things that you got to be ready to do. And so we were ready for the exterior. We weren't ready for the interior. Luckily, we had some time in our schedule, and we just kind of hustled around the house insulating that way. Thank you, Helen. This was another detail, kind of like Taylor described. We sort of identified early, this is where a floor-to-ceiling window came all the way down to our mud sill. This happened just one time in the house. We did the therm model. We didn't really, we don't like the way that therm model looks. The series of events, all the sequencing and everything that it would have taken in order to get some insulation just in that one spot outside. Again, like Taylor mentioned, the house at this point in the design, we were meeting the passive house standard. Because it was a slab and because of our thermal break on the inside, we weren't overly concerned about sort of dry rot and mold damage over the 25 or 30-year time period that it would take for this to happen. And I mean, that's a pressure treated mud sill. We have foam there at the edge. So our sensitivity to this and our nervousness about this detail was actually, it was pretty low. Because of all those things.
Yeah, wouldn't make it a constant, a common detail, but
yep.
One little spot, no big deal. And this was another one of those elements where we had to get a little bit fancy with the thermal bridging issues. These windows, and there's a few issues with them. They're beautiful. They bring a lot of natural light. They really play up the hallway and the way light moves across the space, and it really makes the clients just love this. Was one of their favorite windows in the whole house. They walk past it as they go to their master bedroom, and that repetition is just kind of these architectural elements of the windows with the fin, where just all that was great. And again, light is such an important thing, which we're going to get to, so we're okay with some of that. But of course, with that came some detail challenges, and so probably the next one. Yeah. So.
Taylor says fancy, and when any architect says fancy, a builder hears that as kind of, oh no,
expensive. Like
pain in the neck, yeah, time and money. But again, like Taylor said, this was a trade-off. We knew what we were getting into. So it's kind of tricky here. The takeaway of this is that in between these windows, instead of using 2x8s, which was our common wall thickness, we went down to 2x4. The ThermoSafe, the Gutex that we were using for the exterior insulation, we also put that on the inside because the thermal bridging was so bad. It just in these spots, it's kind of like it's all wood. You've got a lot of frame. You just got a lot of heat transfer that can happen through there. So we really needed to insulate that. And then the other thing that we realized through this is like you've got 5 windows. You could have 1 window there. It'd be a giant window, but you've got 5. You've got a multiplier of 5x of all the air sealing tape that you got to do around each window. Air sealing, the insulation that I was talking about. So we kind of realized, Taylor and I did through this process, like, oh, that's why passive houses kind of have a distinct, like you can kind of spot them sometimes. And that was one of our goals in this project, is like, we did not want the house to look like a passive house, or, the commentary of like, oh, why does it look that way? Well, it's really energy efficient. Oh, okay. But we also learned like what creates that phenomenon. It's all energy, it's efficiency driven. So and that
was great. That's what was great. I mean, actually, there was no thermal bridging with this detail. That was great. Besides the frames that all have a little bit. Turns out the detail still worked out. It was more about the complexity of the installation than the energy model itself, except for, of course, as Kevin mentioned, we'll talk more about the windows here soon.
Okay. Good.
Yeah.
All right.
All right. Now, flow of light. Well, As you can see, as we all are acutely aware of, we live here in the Northwest. It gets pretty dark in the winter. We've got some short, dark days, and those days can really affect our moods and our health and all of that. So, of course, getting the light right in a home is critical. So again, it kind of goes back. Here's a good shot of the courtyard and those windows above and the big sliders below, kind of showing our southerly placement. And we're going to talk about in this section first window quality. We'll talk about the actual windows we use. We'll talk about the window placement and why, and then we're going to hit up a little intelligent lighting. So the windows we use on this project were from Unilux. These are made in Poland. And European windows, triple pane.
It's Germany, man.
Oh, is it Germany?
It's
the
Germany.
glass is from Poland. The frames are from Germany. Sorry. But we use the Unilux Design Line 0.7, which is their certified pre-certified passive house window. You get triple pane. It's all wood window except for aluminum clad on the outside. Just really energy efficient windows. Also the sliders as well were from Unilux.
Yeah, the air sealing component, that's as you look at the window market, you can very quickly find the manufacturers that tailor their windows to the passive house community, because all of the sort of rigorous metrics that you have to enter into the Woofy model, they're transparent about that. The manufacturers are, and they provide that info. Not all window manufacturers are like that. And then the air sealing is the other big thing. So
I'll definitely say that the quality of the windows really the client was really sold on. This is one of the little mini tip is to take your clients to window showrooms and kind of play around, and you can feel the difference between a window. There's other manufacturers make great windows around here, but you can go see them, feel them, touch them, and because they are more expensive, but their value is incredibly evident right off the bat. So to this client, it was very worth it. There was never any question that he was going to use. As soon as he saw them, it was like, we're using these windows. Absolutely. No question.
Yep.
They're also beautiful.
Yeah.
So, of course, placing the windows, again, this kind of goes back to the courtyard. We didn't mention it before, but, with different patterns, place it on the south, bring in a lot of natural light. And, the different arrangements, like the one on the right where you can see the skinny long window. We mentioned that performs better. Yeah. So now we get to one of the more fun parts of the project, which was this mega skylight. Actually, in the slam, we just found out that Lucas was telling us we did get this as a Lamilux Skylight. We got it from 475 Building Supply, and apparently this was at the time at least the largest skylight and passive house skylight in North America. So it was 6x6, and it played a couple of different roles besides just the flow of light. But that's what we'll focus on that. We put it right over the stair in the middle. That light flows down through the inside of the house, really brighten up the interior. The clients mentioned they never have to turn the lights, barely ever have to turn the lights on during the day. And this is one of the main reasons for it. It was really cool.
The other thing that we were running into is the Woofy model, the energy model, kind of in concert with FIAS. You're really chasing four main metrics, right? Your overall heating demand, your heating load, your cooling demand, and cooling load. You have to balance all of those. And we were beating let me make sure I get this right. We were beating the heating load enough, and we were losing on the cooling load. So what we needed more sunlight, direct sunlight in the house, worse than we needed fewer holes that we could afford to lose. Yeah. We could afford to lose the heat loss because we needed the gain in the winter. So it's a little counterintuitive. It's one of those things. Again, we're kind of plunking things in the model, and if the bars move the way we want them to, then it stays in there. And if they move the wrong direction, we plugged it out. In this case, we started with a much smaller skylight, and it just kind of kept getting bigger and bigger. And we said, well, let's get on their website. What's the biggest skylight they have? And it was like 6x6 is like, great. Our stairway is almost exactly 6 feet wide. This can go right over the middle. And it was a fairly late ad, one that, like, if we're being honest, it's like now we can't imagine the project without it, because it had so many benefits. Yeah,
absolutely. So this is kind of showing those benefits. You see in the image on the left, we kind of have this feature stair, again, located centrally in the house. So a little bit further away from all the big southerly windows. This, because on the north side had so few windows, we kind of oriented the skylight as far to the north as possible to help bring that natural light down into the back. And it really just, it's just awesome. And the way it lights everything up. Again, they don't have to turn on their lights. Everything's, you know, just kind of really cool feature. Yeah. Yeah, that kind of takes us to ultra efficient lighting, or intelligent lighting, as you call it. I mean, you know, we don't have to use a lot of light in this project, but of course it does eventually get dark at night. And so, you know, throughout this project, we used all LEDs, of course. So even the feature lights and everything's 100% LED lighting. In the cove lighting, you can see on the image left, the blue light, and then the, you know, the feature lights. So thus energy efficient, as well as all on photocells and timers.
Yeah, that was the biggest thing is, you know, then like most, it's like a person, an adult can be very mindful of turning lights on and off. If you've got kids, all that kind of goes out the window. And so, pun intended,
Yeah.
but so we put as many lights on timers, like the lights on the stairs, like they had louvered step lighting. Those are on a photocell. So it's like, there's no way those turn on unless it's dark enough for them to turn on. And we, like most of you probably know, photocells are so cheap, like it's tiny, and it's, you know, a very small accommodation, to, over the course and the life of the house, have a really big effect.
Okay, now we come to the flow of air. I think we've all kind of noticed, we've had some issues with air quality late this summer. Of course, that doesn't seem to be going away anytime soon. You know, with the wildfires and so forth. That's yeah, an unfortunate reality that we're all going to live with. So, but you don't have to live with it in your house. And of course, that's why one of the main reasons that you know, we think about the flow of air when we're designing these homes. So the four things we want to talk about in flow of air is, first, air tightness. We talked a little bit about that, so we'll go quickly through that. But then that does relate to the blower door tests, mechanical placement and where to put and what kind of equipment, and then how to test that. We haven't hit it too much, but of course the Wolfie model is a testing method. And one of the big things about passive houses, of course, they get tested. And so you don't get certification without that testing.
So yeah, this, as a builder, passing the air tightness test is the most daunting part of building a passive house, because number one, it really kind of points directly to your abilities as a craftsman and as a team. And it's also, it can be very difficult to fix. Like, even if you do a preliminary blower door test, you can walk around with the sort of the incense, the smoke sticks, and do the thermal imaging, which we did. But there's always the possibility in your mind that you've come all this way with the client. The client is jazzed about passive house. They want to live in a passive house now. The last thing in the way that could possibly screw that up is you, the builder. And so it's terrifying. And it was a moment. We had a talk with our crew at the beginning of this, and we said, look, everybody looks over each other's shoulder, call it out. You're not going to get in trouble for telling your partner that he did a sloppy job with that tape. So there we all are, our hands and knees. This is underneath the slab. And if you begin the project and you go through the whole project that way, to where like everybody feels accountable, everybody on the team, you scare your subs whenever they walk onto the site, let them know the weight of this and how important it is. You hang signs, you do all of that, because the air tightness thing is just paramount to the whole thing. So yeah, conduit as it comes up through the slab for the kitchen island, slab edge, all of that stuff. Tapes are fantastic. Expanding foam is not so much. Tapes stay flexible as the building moves over the years. Foam becomes rigid and can become detached from the two things that you're trying to close the gap around.
Don't even start with me with caulk.
No, yeah,
Don't
caulk
even
is
start.
just right out. Just get out of here with the caulk. Tapes for the win.
Yeah.
So yeah, there we go. So what we did in this is our air barrier was actually the OSB, the structural sheeting. So no paper. We're trying to not just throw materials at this and say, well, our air barrier, it needs to be a paper that we have to tape. And because we started out that way. In our fear of missing certification, it was just like, let's do this material for this and this material for this. And we went through this process of kind of peeling things back out, partially for budget, but partially like the whole house does not need to be belt and suspenders. So what we ended up doing, our OSB was our air barrier. This is liquid flashing. This is Proseco. We did all of the panel edges and all of the corners. You can see it around the window bucks. We did not hit the nails in the field. If they were properly driven, we didn't touch them with the goop, and it worked out just fine. So that was a good moment.
Yeah, and so just to stress the air movement through the wall itself is a huge thing. Besides just the indoor air quality, which matters a lot, any air movement through a wall drastically reduces the listed R value of that material. So really keeping that air movement. Also, what moves through air is moisture. As the air moves through it, vapor and moisture. Vapor can dry by itself, but they're related, and so you're really trying to control all that.
Yep. There's Tom. Tom was our rater. This was, man, I can't remember if we did 3 or 4. I think we did 3 total blower door tests. We did 2 during the course of construction, and then the one at final. So I'm sure most of you know the kind of mechanics of a blower door test. You sort of seal up the house, put the fan on it. It's got an anemometer, and so you know how much air is crossing over the fan at a certain pressure differential, right? 50 pascals. With FIA certification, the blower door test, that metric pops up twice in your pass or fail. One is a prescriptive, you have to beat this number. And that's what that chart at the bottom is. So we had to do one target air change per hour CFM. And we were down at 0.42 in the end. So one quick funny story. I think it was our preliminary blower door test. We had the house completely sealed up. Tom started the fan. He said, man, the numbers are really off. Like there's a hole somewhere. Like we forgot to plug up, because you're allowed to like plug up holes, like plumbing vents that will eventually get filled with, the water in a P-trap or whatever. It was like, air's coming from somewhere. We raced up to the bathroom. There was an open plumbing waste vent. And so all of the air that was going out of the house through Tom's fan, air directly from the sewer was being sucked into the upstairs bathroom. And we were running around, shut it off. So and it was hard to get it filled the house with sewer gas. It was a good one. But once we plugged that up, we were able to walk around. A funny thing, we don't have a picture of this, but I want to mention our plywood window bucks that go on the inside of your window's rough opening. We had air leaking through the grain of the plywood, right? Because we did not liquid seal. We sealed the connection between the window buck and the sheathing. That inside corner, of course, got air sealed, but the end grain of the plywood we left off, and there was air coming through those tiny little holes like crazy. So we went around with tape, not caulk. Went around with tape and just taped up the edges of the plywood, because you're after every little bit, right?
Absolutely.
Did we talk enough about that?
I think so.
I think we talked enough about that. What's this in here?
The
for?
mechanical?
Oh, mechanical.
So yeah. So a big part of the flow of air is the mechanical system. The first part of that is trying to locate that as centrally as you can. It's more efficient because your duct runs are going to be shorter. Getting away from exterior walls helps. You're not running any ducting or anything in the exterior, like the roof cavities or wall cavities. at all. And then in our case, everything inside the air barrier is possible.
Yep.
Yeah, so there's the laundry mechanical there in the middle. One thing note, we really crammed a lot of mechanical. There's the laundry is in there with the what we use as the HRV for ventilation system, but
yeah. So there's in that, and you can probably see the scale in that room that's highlighted. There's a sink. There's a stackable washer and dryer. There's a Zinder Comfo Air 200. It's the smaller of the. It's not the 300. And then the air handler for the mini split system. All of that was crammed in there, and the ceiling is still open. So that the prep your owners for flexibility. Wherever this is going to go, all of that really needs to stay open for maintenance, and don't let homeowners get the idea that their laundry room is going to be kind of this finely finished space, or their mechanical room. Like, we just kind of chose to combine the two in this, but
yeah, it was a tight house.
Yeah. And in this too, so like Taylor mentioned, we're staying out of the envelope, but it was helpful for us. The two walls that are highlighted, they're blue and yellow. We thickened to a 2x8 because this is on the second floor. We needed to get down into the ceiling of the main level. And so we found two walls that we thickened all the way up to, I think it was like a 2x12. It's like, yes, we can lose inches in the closet. And yes, we can lose a few inches in the bedroom there, in the main bedroom. So again, planning for flexibility, be ready. Don't design such a dimensionally constrained floor plan that you can't very easily and quietly just make a wall thicker to make everything work. And then the same thing, I would say that pinch, we felt from a mechanical system dimensionally, we felt that pinch the most in that hallway, because we had to get the main trunk, the distribution trunk of the heating and cooling system along that long axis of the house. And so we rolled the trusses, insulated the trusses, and then softened it down underneath that. But there's a lot. We all know those ducts, the return ducts and supply right there at the plant. I mean, they're bigger than any of us ever expect them to be, right?
Yeah, potentially, and we've done this on other projects. Some of that flexibility might be using as opposed to a ducted. This was a mini split heat pump system. There are other those cassettes. There's wall mounts. There's other ways to do it, which might consider as well.
There's Tom again.
Yep.
This so this was another surprise for me. Was the basically commissioning and the testing of the ventilation system. I knew it had to be done. I think I budgeted in the schedule like a half day, like 1.5 day, that Tom could come out, and so you can kind of see him. He's testing the airflows at each port. We used our mechanical trades. This was Cascade Comfort Systems. They were excellent through the design and installation part of the project. All of that went great. We just had nothing but high confidence in them. So me, kind of without asking anybody, not realizing that I needed to ask, thought, okay, we can budget half a day when Aaron Barnett of Cascade and Tom can be out kind of at the same time. And you're kind of opening and closing dampers, and you're sort of twisting knobs, and it's very complex. It was 2 3/4 days. We spent about 6 hours, and we had to come back because we couldn't get it dialed in, right? So the heating and cooling, I hope I get this right. The heating and cooling needs to be within 20% of design, and the ventilation needs to be within 10% of design for your airflows. That's tiny.
Yeah, for passive house.
For passive house, yeah. That's right. That's a really thin margin when you're talking about, we need 35 CFM to this room. We're trying to dial in to within 3 CFM airflow, in each place. And so obviously we did finally get it done, but again, I thought, man, everybody's awesome on this. We're going to test it. We're going to prove to ourselves how awesome we all are. And it's not that they weren't all, it's just, it does take a lot of fine tuning because every house is essentially a prototype, right? Every house is different. Duct runs are, different lengths, and there's just so many variables. So the importance of this really jumped out at me.
One really nice thing, just last bit about using a Zender, pretty nice for passive houses. One, because they have the flex duct, that was pretty nice, and then also they dial in. You can control the airflow to a much finer degree than a lot of other HRVs, which was helpful in that commissioning process.
Yep.
All right. Okay. Well.
Yeah, so we're going to kind of summarize. We're through jabbering about the building itself. We're going to do a Q&A here in just a few minutes. We wanted to kind of loop back and sort of talk about how all of the details that we just covered sort of have a bigger sort of impact. So people often ask about the name of our company and where we found, like how we came up with it. And so the story we tell, and like we mentioned at the top of the talk, Taylor and I met our freshman year in architecture school. So we've known each other for a really long time. Through the course of architecture school, obviously we stayed close. And we came across a book, and I think it was our architectural theory class, written by John Ruskin. It's called The Seven Lamps of Architecture. And it's written a long time ago, but the takeaway, the thing about this book is basically, if you make fantastic buildings, everybody around and in those buildings become better people. Like, one of the ways that we can make society better is by doing a better job building. And if you pay attention to the things that are important, and you're honest with yourself and the building, and integrity, I guess, is a part of it, the word that kind of folds into all of this, then it's not even an architectural improvement. Like, society just becomes better, And so we took that, and if kind of, when we started the company, we didn't imagine that we would be building and designing passive houses. We got into sustainable building and design gradually, but we sort of kind of continued raising the bar because we realized that so much of this is really just kind of doing a good job, right? Again, it's kind of the craftsmanship, airtightness is like, man, that just means you build it better. And so all of that has kind of brought us here to this point. And so the part of our other mission in this, and what we want to do, is kind of give back to this community that we have learned so much from, right? And one of our favorite things about the eco building community is it's essentially open source. You share details, you share trades, you share tips and tricks for like all of those things, subcontractors, all of those things. So we want to talk a little bit about, how do you talk to owners, clients, consultants about passive house? Like, what do you prepare them for, right? How much does it cost? That's like everybody's questions. How much does it cost? That's probably not the first question they should be asking, but that's usually is. So how do you talk about cost and schedule? How do you, how do you work with trade partners, with electricians and plumbers who don't know what passive house is, they don't share your passion, but if they mess something up, or if they could derail what is otherwise a project that's on course. So kind of spreading the mojo that way is important. And then we've watched it. Taylor and I have watched clients' faces kind of glaze over when you start talking about what an HRV does, right? And so what do you say to clients, and how do clients end up feeling about passive house, right? And then the last thing is what we intentionally did with this project is, like, this is a good example. It's like, most passive houses, the windows are pretty square, or pretty close to square. And it's like, why is that? And we told you guys, this is why it is. We paid the price for that. So if you if you are ready to kind of improvise or like sort of riff on passive house vocabulary, you're going to learn why it is passive house vocabulary, and you're going to learn all the ways, all the other things that you're going to have to do in order to kind of balance everything out.
So yeah, and the final part of that is, we're the experts. They came to us. So, we really feel like it's our responsibility, going back to what Kevin said about being diligent about how we build and how it can affect society. Well, these buildings have a carbon footprint. These buildings affect our neighbors. These buildings affects the world. And so therefore, it's on us to as experts to help push this. We're the builders, we're the architects, or even owners, like just not, all the consultants and, everyone that's, all of our partners, it's on us to really kind of drive that. And so there's a few.
Yeah, so this is a Henry Ford quote, and we have found ourselves kind of coming back to this. If I would have asked my clients what they wanted, they would have asked for a faster horse. So we are the experts, like an example of how Taylor and I have kind of implemented this. We don't talk to our clients about an HRV anymore. It's just in the design. We talk to the builders and we say, this needs to be in the budget. We need to plan for this, but we don't often present it as an option because we know it's better. And most of the time, if the owners have the money to build a house in Seattle that is kind of a market house in Seattle, they have the money for a nice HRV. And it's like an airbag in a car. We use that metaphor a lot too. Again, not with the clients, but there's people out there that if they could choose to not have an airbag in their car, they wouldn't want to pay for it, even though that's an entirely irrational decision. So like an HRV is the sort of the kind of the construction parallel of that for us.
Yeah, no more trickle vents.
No more trickle vents in windows. Rain screen is another example. Yeah. Like we just kind of tell all of the builders that we work with, this is going to be a rain screen project. We can talk about which system it's going to be, but we don't want to try to educate our clients on why a rain screen is better. And if they ask, we can jabber about it forever, clearly, but they don't. That's not what's on the list. So when in the industry, we talk about lots of insulation and building an airtight envelope. We don't want to talk about if that's easy or hard and what material you use. None of that kind of goes through.
Yeah, these are all the things we talk about. Airtight, that's us, as professionals. Balanced ventilation, passive house windows and doors, efficient heating and cooling, net zero. That's all great, but we're not talking about necessarily the benefit to the client, and that's what we have to focus on when we're talking to clients. Is before cost. We're talking about benefits and what the value is, and we're trying. That's everything that we're trying to push, because those benefits and values apply to them in their own home. It's not necessarily about it being carbon neutral or helping the environment. That's all great, and that's what happens. But to sell this, to talk about passive house and get people jazzed about building them, or at least super energy efficient homes, you talk about thermal comfort instead. You talk about superb indoor air quality, smaller mechanical, saves money, lower your carbon footprint, and you're talking about, no monthly bills. So, and that's all what comes with this project. This is a good time. Like, for example, we didn't tell the story, but this is a story of when this, the owners left for 8 days to go to, in the middle of December, in the coldest time of the year, turned all of their heating and cooling off, only ran the HRV, 8 days on a vacation, came back. It went from 71 degrees in the house to 68 degrees. And, those are the kinds of stories. You're free to take those and tell that to people, because that's a true thing that happened. And, it's just, that's what we get excited about.
Yep. Oh, there's all our equal signs.
Whoops.
Is that it?
No.
There's a few of our trade partners. Go ahead.
Yeah. We just want to kind of recognize we had a couple of our trade partners that really made a difference in this project to us. 475 is great. We got got the Skylight and a lot of the good advice from Lucas, and a lot about building foam free as much as possible. Aaron Barnett, again, Dan Whitmore, some of the detail, that detail for the Kevin was mentioning on the little chamfer and the foam, that was Dan. He really helped me with the energy model. This was, learning all the woofy stuff and I think, of course, Tom and Helen.
Tom and
Thanks,
Helen,
guys.
yeah, helped us out a lot.
Yeah.
And they were great. We would almost, I was always nervous about how much lead time I was giving Tom and Helen for one of our preliminary blower door tests or an inspection, and both Tom and Helen were just fantastic. Tom was like, "Don't worry about it. I live nearby. I can I can swing by and take a look at your jam insulation before you cover it." Just like that, no problem. So
we just leaned on all them and some others, and then the rest we pull along ourselves.
Yep. Yep. All right.
That's kind of it. This is one more, just kind of a thank you. All right.
Oh yeah. That's so much better. That's the resolution. Like you saw the college picture, like we got to bring it back around.
This is 24 years later.
Yeah, that's right.
But
All right. So think now we have about a half an hour for Q&A, which Taylor and I enjoy just as much, probably more than just hearing our voices drone on. So if I think what we set up is if anyone has questions, submit it in the chat. We'll kind of read it out for everyone, and then we'll go from there.
Right. So this is Wendy again. I've got a few Q&As in here.
Okay.
Quite a few of them are from Helen, but we do have a few others.
Okay.
So let's see. Let's start with Patrick. He asks, how do you balance giving the owners control over their house's systems, mechanical lighting, etc., and making sure the house as a whole operates at peak efficiency at all times?
That's a great question. So the way that all of these mechanical systems now are designed, especially like the split systems, you kind of tell the owner to it's running now, just don't touch it. It's just like the temperature swings inside a passive house are so less drastic. They're so much shallower that you don't get the stratification. Like it's not hot upstairs and cold downstairs. So ideally they're designed to where you don't need to turn the dial in the morning when you get out of bed because it sank to 64 degrees in the house, right?
Yeah, I think it's a good time to mention that this house is not a tech house. It's not automated. It's all pretty simple stuff. The HRV is just a fan with a heat exchanger. The mini split system is controlled with a remote, so they do have control, but it doesn't, when you set it up right, you get your good HVAC folks and good installers, then it kind of operates on its own.
One more point on that. The early feedback. So I talked with the owners after they had lived there. Let's see, they moved in last sort of August. And it was about midwinter when I spoke with them, and they said they prefer not to run the mechanical system. They prefer not to run the heating and cooling. And he said, we just had to get used to when we needed to open and close which windows around the house. Again, like all of this is set up where you don't need to do that. They just chose to do that. But once they figured out, it's like, okay, it's reached this temperature inside. We better open up some of the upstairs windows and like the window on the west on the lower level, and then that gets a good cross breeze. And so there's a little bit of that, but again, they chose to do that.
Yeah, and it's probably another thing worth mentioning is a lot of people, there's a misnomer about passive house that, I can't open my windows. We've heard that many times. That's not the truth. So you can build a passive house and you can open your windows. The system's fine with that.
Yep.
Cool. Another one from Patrick. Is there a $1 per square foot premium for passive houses? And if so, what kind of payback period do you typically see here in the Northwest?
Great question. We get that one a lot. You're not going to like this because it's kind of a qualified answer, but the premium, the sort of delta between whatever regular house, let's call it code minimum house, and passive house, a lot of it depends on what your starting point is. Like, would the owners have already picked wood windows anyway? Like, where are we gonna have a $45,000 or $50,000 window package anyway? So when we step up to 68 or 70, that's less of a premium than, like, I've never looked at windows ever in my life. I can't imagine ever being excited about one. Give me the code minimum. Well, then the difference is just a lot more. I will say it's also that premium is getting much smaller because there's more products on the market. You have more choice with ways to, you can still use foam if you want to. And there's more price competition, and there's more trades out there that understand that there are builders who are paying attention to stuff like thermal bridging and all of that.
Yeah, the numbers that I've heard, just to give you some kind of number, it's going to be a range. The numbers we keep hearing thrown around, this is just a one-off. This is too anecdotal of this project to say what the premium was, because there's so many unique details in the way we did it. I mean, we could have built it without a premium, but there would have been some trade-offs, right? So in this case, though, I've heard anywhere from like 3 to as much as 10%. Is kind of the numbers that we've heard the most. But again, that really is a very much qualified depends. Right?
It also depends on how, like, whoever's building it, has that builder ever built a passive house before? Because if they haven't, they're going to be terrified, like we were, of missing the blower door test. So they're going to take their time. They're going to be maybe overly cautious. If they've done a few before, that's the quote I remember hearing. Dan Whitmore said it: the very first passive house that you ever build, you'll wonder, or you'll think it's impossible to do. It seems like Mount Everest. The second, third, and all the way through, you'll wonder what you were ever worried about in the first place. And that kind of does hold true. Like just like everything else, the first one's the hardest. So to answer your question, that delta, it depends on so many things. If the builder is well versed in passive house, they're not going to pad their numbers out of fear, honestly, as much. Yep.
A question from Grace. There are a lot of materials that go into a passive house. How do you address the materials in terms of life cycle, embodied energy, etc.?
That's a great question. So, and that was something we did put a lot of thought into. There are, of course, choices. I think, the biggest one we would probably highlight on this project was the exterior insulation. You could put EPS foam in there, or XPS, or some kind of foam like that. That's got a lot of embodied energy. So that's why we chose wood fiberboard product. The Rockwool wool Comfort Bat 80s are also really good for embodied energy. Passive house certification doesn't put any requirements on that per se. So a lot of times what we say is like, well, if you want a net zero home, but you also want to be, Living Building Challenge, or, get Emerald Star or something like that, passive house is the best place to start. And then, they're seeing this still, right?
Yep.
Best place to start.
Oh,
you're gonna, yeah. But it doesn't necessarily address all of those things. Its main focus is to just to reduce the amount of energy used to as much as possible. But we thought about it, but it's not necessarily part of the certification process. So, yeah.
Yep.
Okay, let's see. Next question from Helen. Can you talk about some of the client requests in the design process that made passive house challenging, and what you did to resolve that or convince the homeowner to go in a different direction?
Oh, man.
Well, we were first we'll say first off, we were lucky. They didn't know they wanted a passive house. They didn't know what that was, but they definitely wanted to be very energy efficient, and good indoor air quality and all the stuff that passive house gives you. Did they ask for something? I would say one of them was that they compromised on was the dryer. We used the closed dryer. We talked them into a heat pump dryer versus a standard venting dryer. When we talked about air sealing, this house didn't have an external hood vent. We had a recirculating hood vent that didn't tie to, but worked in conjunction with the HRV system. And those two things really helped the energy model a lot. If it weren't for those two, it wouldn't met that level, the old certification back in because this is a 2015 plus certified passive house. But yeah, that's what.
And in each of those circumstances, we basically told them, this is what's better. This is what helps us meet certification. Let's start with this. If you use the clothes dryer for a year and it doesn't work, or you hate it or whatever, then we'll change it out and put a vented dryer in. But we know what's going to happen. Like, we're going to have to go through the envelope, and the building's not going to perform. So we kind of expressed flexibility, also expressed higher stakes for kind of coming back in with the retrofit, and just kind of let them know, it's like, we don't really want to do this. And there's a lot of good customer reviews for the clothes dryer that we picked, right?
We're lucky. The old condensing ones are pretty terrible, but the heat pump ones are quite a bit better. So that helped a lot.
Yep.
Okay. Next question from Helen again. What was the ultimate why behind the homeowners actually pulling the trigger on certification, as opposed to building to the standard and not certifying it?
I think that it was an ultimate why. I felt like we just sort of evangelized it a little bit, and then he just kind of went for it.
Well, because they're, from their perspective, what they really wanted, they're both incredibly noise sensitive. They don't want to hear airplanes and lawnmowers outside. And which is also why they don't run their heating and cooling normally, because they don't even like the sound of air coming through a register into the room. Like, they hear it and they're sensitive to it. We almost replaced all the doorknobs in their house because you could hear the spring inside, because now it's so quiet. It's like, you'd never do that. But what we basically told them is, they wanted energy. They wanted higher, because they lived in a 4-star built green townhome that we built for them. And they said, this is great. We want more. We want it even more efficient. Can you do that? And we said, yes. And then there's all the other things, like the acoustical performance and just kind of lighter mechanical equipment. They already wanted all of that. And so we just kind of told them, like, look, if we do all of this, we're so close to certification. Like, we are right there. And him mostly, it was just his mentality. He said, well, if we're right there, we just need to do it. Like, if we're that close, we need to cross the finish line, and let's do it. And so he became excited for all of us. Like, he knew we had never done it before. We'd never, built a certified passive house before. And you guys think you can do it? Absolutely. It's like, okay, let's do it. So it did help that we were already very close with, they already wanted nice windows. They didn't like crawl spaces, and they don't there's a lot of things that just kind of put them in the right direction.
Awesome. Okay. Another question for Patrick. Do you track or have an idea for the total avoided carbon emissions or reduced energy conservation across your portfolio?
No, I wish we did. I occupancy testing, post-occupancy testing. I mean, we've talked with other passive house builders that have even done multifamily stuff, and it's really, I wish it weren't so rare in the industry. I do know that so the owner is getting a solar array put on his roof. He got it sized to run the entire house and 2 electric cars, and it's an 8 kilowatt system, I believe, or 10. And I think he, not knowing what his future EV draw would be, he padded it a little bit. But so for what that's worth, I mean, it's a 2,400 square foot house. If you take the electric vehicles, the last number I heard is about 3 kilowatt hours per year.
Yes, that sounds right. Yeah.
That draws. So, I mean, his cars are half of the reason for the array. So yeah, that's a good question. We look into more monitoring for sure.
I can't tell. Oh, that's gone away. Okay. Skylight in the Woofy model graph you showed in the is the skylight in the Woofy model graph you showed in the beginning?
I think it is. Let me see if we can go back here. I've got to click that and go here. And then what do I do?
We're doing it. I think are we sharing? Yeah.
There we go.
Sorry, it's so small. This.
Well,
we did pretty good. Well, I mean,
yeah, there you go.
Even there.
Which one is it? Sliding door west ACB.
Oh, Skylight.
Skylight. It's the very bottom one.
Yeah.
So that the solar gain during the cooling period. So you can see it's the highest solar gain during the cooling period of any of the windows. And we had room though to take the hit for that because we needed more of the blue bar, which is solar gain during the heating period. So that was again, like the model really it helps so much to like you hear the term calculated risk. Well, like it does the calculating for you, so it like kind of takes the risk out of it. But yeah, to answer the question, it's the one down there at the very bottom.
And of course, it's on the top, so it's always going to get. That makes sense, right? That it doesn't have east and west. It's even in the east and west, it's getting a lot of gain throughout the day.
Yep.
Right. Is there a HEPA filter for incoming air on your HRV?
I don't know if it's a HEPA.
Yeah, it's not a HEPA. It's a MERV 13. It's kind of hospital grade filter. Actually, there's a couple of filters. There's a 13 and then a 9 down the road. So it's like 2 filters. But it's not a HEPA.
Yeah.
It's just MERV 13.
Yeah.
Okay. Helen wants to know if they like the heat pump dryer. Yeah, she's guessing that you didn't get a call back.
No, we didn't. No, in fact, I was out there doing a little bit of warranty work. So one thing to kind of keep in mind, one of our warranty items, we didn't have any of the HRV ducts insulated because it was all within the space. But the laundry room is so humid. There's so much relative humidity that in the winter, when the outdoor air was coming in, just the short, we're talking like 3 feet or less of ductwork that goes into the HRV before it's been preheated, that would build up condensation like crazy when they were doing laundry. So I went back out and insulated that. They were having similar issues with their heating, like their trunks for like when they would be cooling and pushing cold air out through the supply trunk and doing laundry, that would condense and drip water on the floor. So we insulated both of those with, I think it was R8 that we wrapped on there. But no, they do love the dryer. We didn't replace that. They were okay. We kind of did, it's kind of a code trick for the kitchen recirc. We had the hood that's got the charcoal grills. The exhaust port for that thing is right up by the ceiling. And I think 6 feet away or so from that is an HRV intake port. So the idea is that you don't have a 300 CFM hole in the building that's pumping air straight out, but the HRV is kind of vacuuming up cooking odors and moisture from the kitchen that way.
Awesome. Okay. Patrick says, a lot of today's discussion is centered around energy efficiency. Has your company ever delivered any projects with rainwater harvesting, efficient landscaping, efficient fixtures?
Yes. Yeah, we had, I think the biggest one, we had some clients that bought land. They bought 10 acres kind of out near Sumner. And how big was their cistern? It was like 60,000 gallons.
No, it wasn't that big. They wanted it to be that because that would have handled all their agriculture too. I think it ended up being like 15 or something.
Oh, okay. Yeah. But yes, we've done, as we were kind of ramping up to this point, we did do, I don't know how many Built Green projects we've done.
A bunch.
A bunch.
Both built-in design, all of those have, we've several 5-star Built Green projects, and all of those have a figure. I think all of our projects just have that as a baseline anyway. We tend to just pick low flow fixtures and all that kind of stuff. Yeah.
And not to mention now, because of FIAS's partnership with the Department of Energy, I believe.
That's right.
That's kind of fixture flow is another sort of what's the word I'm looking for? Like it's a hard requirement that we
like prerequisite almost. They partner up with the Department of Energy, and so that does govern a lot of things like how much water can flow through the pipe before it gets to the fixture furthest away from the water heater. So you got to fill, it's like 6 gallons, and it's got to get up to temperature in a certain amount of time. So there's a lot of so now Passive House, by teaming up with the Net Zero Ready DOE stuff, has overlaid a lot of that requirement into getting a certified Passive House.
Yeah. Tom, we got that mostly right, didn't we? I think we got that mostly right.
Yeah, should have Tom. He knows better than us. Than Helen.
Speaking of Tom, he has a suggestion here. He says, I'm not sure if you can put a residence and EPA portfolio manager. He doesn't see why not. The owners could share the projects and get City Light to input utility usage data. Then you could review it. So
let's talk, Tom.
Yeah, let's do it, because
I would be into that.
He would be. He has kind of like laughed at himself. He's like, I could have bought a really nice sports car. Instead, I bought German triple pane windows, and he's thrilled with that decision. So when the Passive House plaques, came out, we ordered him one, and he's like excited to kind of put it up. And so he is, he's been fantastic at kind of giving us continued feedback about what it's like to live in a Passive House. And so that's been good. Let's definitely talk, Tom, because the owner would be thrilled.
He says to let you know about the cool motion sensor that turns it on.
Oh yeah. So that's I don't remember the numbers of the metric, but what Taylor was talking about, you take the furthest fixture away from the water heater, and the temperature you turn the hot water on at that fixture, and the temperature needs to rise
10 degrees
before a certain amount of flow has passed through the filter. Through the fixture. Yeah. And so the way that we solved that is, so we put a recirc pump on the wall for just that line, and we tied the power to the recirc pump to an occupancy sensor. So I think it was a Honeywell. So Honeywell makes occupancy sensor, and they have floating vanity, like their cabinets in the bathroom are floating. We put the occupancy sensor underneath them so it catches the motion of their feet. When they walk in the bathroom, it immediately turns the recirc pump on, which allows us to meet that metric. We've heard of other ways of meeting that, where you can put like an InstaHot, like a supplemental heater inside the cabinetry there that will help with that. And it just it seemed less in the spirit of the rule of the why it's there. A little bit. Yeah, it felt like a hack more than a pass. But and that was another thing that we were nervous about, to be honest, because again, others have told us that they did it, and by others I mean like internet forums of like other energy conscious builders. So we were nervous about that, but in the end, it worked out great.
Okay, Tom throws in, it's 10 degrees before 0.6 gallons comes out.
10 degrees, 0.6. Thank you, Tom.
I had 10 and 6 in my head.
Yeah.
Yeah. And then Austin says, is that a Grundfos pump? I used to use those all the time in Santa Barbara.
Yep, that's the brand. Yeah, we looked at those.
Oh, and actually it says this is Lucas Johnson. I'm maybe signed in someone else.
Oh.
Okay, and the last question I've got, unless anybody else wants to throw some out there. Helen would like to know if you saved your design iterations and how they changed against the Woofy model along the way.
Ooh.
We did save them. Yeah, I know there were a lot more windows on the north, like Taylor mentioned.
And east and west bigger overall. The east was close, but I mean the west was close. Like Kevin mentioned, they were taller. They just got shorter because we were trying to do this ribbon of glass. And then on the east too, we like eliminated a couple of windows. Yeah, that was that's the windows are one of the biggest drivers of how these. I mean, they're basically holes, and I mean, even windows as good as these are basically holes in the building. So, you got to be real careful with those.
Yep.
But the shape was generally right.
The shape was generally
the garage, the courtyard, the L shape. That's always been there. We tweaked the detail on the front where the slats in the wood. That didn't have anything to do with energy efficiency. We just played around with that.
And I think the owners, another funny change, kind of mid-course, the owners added, initially we only had steel shades up high above those sort of 5 vertical windows. The owners actually wanted to add another shade above the slider at the living room, so directly below those. And
ended up being good.
It was another positive change. But that was another interesting thing, just the dimension of those shades.
It changed a bunch.
It really, and it all matters. So, I'm doing the drawings, and Taylor says they need to be 30 inches deep. And I was like, well, is that 30 inches from the sheathing or 30 inches from the insulation?
From the glass.
From the glass itself. And so we're kind of.
They went from 30 to 24 to 18 to 30. I think a few of them they're not all the same depth because they have different solar exposure depending on the height of the building, the neighbor shadows. You take into account the trees, the houses next door, and all of that is being taken into account. So, and like Kevin mentioned earlier, like that one window our slider was close to the corner, so that thing's in shade a lot. It didn't really need a canopy. It was getting a balance, but the other one did. But it would look funny not to
carry the shade all the way across.
Carry shade across, of course.
Yeah.
Okay, one more from Helen. She says this is her last one.
Okay.
Was the skylight always part of the plan, or was that informed by the model too?
That was really all the model.
All model. It wasn't in the original design at all. We didn't think intuitively that it would make sense, and that would have been too big of a hit. But once we got into it, we're struggling at some point to get like we mentioned, the energy. So get the heating during the cooling period. So I'm sorry, getting the heat during the heating period.
Yeah.
It's very confusing. And so because the heat gain lowers your heating in the heating period. Anyway, so when we added it, it really made a difference.
I think that's all the questions, unless anybody else wants to pop one in real quick. I have to say, me personally, this has been awesome. So thank you very much. And I'm going to shut up now.
For answering all my questions.
Thank you, Wendy, for reading all the questions. Yeah, thank you.
I'm going to release everybody to the networking session. So feel free to head to your table and see if anyone else would like to chat.
Okay.
All right.
I'll see you at our table. Bye.